This is where we left off in our last video. We looked at the graph of the hyperbolic sine, but let's look at the graph of the hyperbolic cosine. Let's get rid of this and look at the graph of the hyperbolic cosine. This was the hyperbolic sine. The hyperbolic cosine. Let me copy and paste it over here. Now, that's the shape of it, as you can see, right? Hyperbolic cosine, the cosh of x. I copied this from GeoGebra. So let's look at GeoGebra. Let's zoom in and then we'll make some adjustments to this thing here. Let's change this to cosh x. Alright, so there we go. Alright. The hyperbolic cosine, the graph of the hyperbolic cosine. Now you notice that you can put in any value for x, but the answer is on the vertical axis will never fall below 1. Alright? So here, remember, the cosh of x is equal to e to the x plus e to the negative x divided by 2. So, suppose you make x 0, as we see here. E to the 0 plus e to the negative 0 over 2. E to the 0 is 1 plus e to the negative 0 is 1 over 2. Which is 1 plus 1 is 2 divided by 2, which is 1. So that's what you have happen right at this point. Right? When you put in 0 for x, you get 1. Now, let's input 1 for x. When you put in 1, you should get a little above 1.5 based on what I'm seeing on the graph. Let's see what happens. E to the 1 plus e to the negative 1 over 2. Now, which is e plus 1 over e divided by 2. We use our calculator for this. E plus 1 over e and divide by 2. So you have e plus 1 over e equal. And then this over, my gosh, it's over 2. Over 2 equal 1.5 something. A little above 1.5. Right? Which is what we got here. If you look at 1, a little above 1.5 right here. So you can put in values, positive or negative. You will always get a positive answer. Alright? But it will not be below 1. Now, the thing is, if you look, for example, at the answer here is 1.5. So the cosh of an angle, theta, is equal to 1.5. From looking at the graph, I expect that theta will be a little below 1. Alright? Now, if we find the cosh inverse of 1.5, we're going to get theta. Let's use the calculator to do that. Alright? So the cosh inverse of 1.5. So cos inverse of 1.5 equal a little less than 1, 0.96. So this is equal to 0.96. You can see it here. So the cos inverse of 1.5. And we could use GeoGebra as well. Look at GeoGebra and see that when we have the answer being 1.5, what we have here, this line is 1, you know. So at 1.5, I want to see 1.5. This is the 1.5 line, and this line here is the 1 angle theta is equal to 1. But it did not reach there, right? It crossed the 1.5. The curve crossed the 1.5 before it reached 1. So it's a little below 1. Just like we saw a while ago. It's 0.96. Now, it would be interesting to imagine that we find the cos of an angle equal 1. What would happen? Let's see what would happen here. Suppose we consider the cos of theta equal 1. Let's use our calculator to see what answer we would get. Now, oh no, let's open our calculator again. Our calculator disappeared a while ago. Alright, so what we have is, since the cos of the angle is 1, and the cos inverse of 1 would be the angle. Let me write that down. The cos inverse of 1 would be theta. I wonder what theta would be. Let us see what theta would be. What am I doing with so many calculators here? We want to find the cos inverse of 1. Cos inverse of 1 is equal to, alright, 0. Cos inverse of 1 is 0. Now, is equal to 0. It would be interesting now to find the cos inverse of 0.9 to be theta. What could theta possibly be? Let's see something here. Now, here we find the cos inverse of 0.9 equal. See what it says here? Inverse hyperbolic cosine is undefined for values less than 1. Alright? Now, let's see something here. Cos inverse of 1. Now, if the cos, call it x, cos of x is equal to 1, then cos inverse of 1 is equal to x. Right? The cos inverse. Now, the cos of x is equal to e to the x plus e to the negative x over 2. And that is equal to 1. So let's find out what x is, right? What the angle is. Well, we found it to be 0 before, but let's play around with this and see. If we multiply both sides by 2, we say e to the x plus 1 over e to the x, which is the same as e to the negative x. 1 over e to the x is equal to 2 ones 2. Now if we multiply both sides by e to the x, we have e to the x squared plus 1 is equal to 2e to the x. So now we have e to the x squared plus 1 minus 2e to the x is equal to 0. Now, suppose we consider e to the x to be a letter. Say p. P squared plus 1 minus 2p equals 0. Let's write it like this. P squared minus 2p plus 1 is equal to 0, right? And then let's factorize this. Can it be factorized? Find two numbers that multiply to give 1 by 1 is 1, and they add to give negative 2. Or negative 1 by negative 1 is positive 1. Negative 1 minus 1 is 2. Right, so it can be factorized. P squared minus 2p plus 1 equals 0. Alright? Factorize here p minus 2 minus 1. You have p minus, let me see, p minus 2 minus 1. Oh no, my mistake here. It's negative 1. Negative 1 and negative 1. So a mistake. So here now, we consider p squared minus 1p minus 1p. It would give you minus 2p, right? Plus 1 equals 0. So factorize these two here. P minus 1 minus 1, p minus 1 equals 0. Remember, I have to practice here factorization of quadratic equations, right? We use the AC method. So it's p minus 1 equals 0. Because we take out this p minus 1 and say p minus 1 into p by p minus 1 is p. And then p minus 1 by into negative 1 by p minus 1 is just minus 1. Alright? So p minus 1 is 0, so p is equal to 1. Repeated roots. So p is 1. So if p is 1, then e to the x squared, e to the x is 1. So e to the x is equal to 1. So we know that e to the 0 is 1, so x would have to be 0. So x would be 0. As we saw, well, we use x as our angle. We had used theta here, but it's the same argument. So cos inverse of 1 is 0. The hyperbolic cosine inverse of 1 is 0. Alright? So we saw that if we find the hyperbolic cosine of x to be 1, when we do our calculation, x would be 0. Right? So the angle that we're looking at is 0 radians. So the hyperbolic cosine of 0 is 1. Let's use our calculator on that to find the hyperbolic cosine of 0. Just to be reminded, so the hyperbolic cosine of 0 equals 1. Alright, it will be interesting to look at what happened with the 0.9. So the hyperbolic cosine of x is 0.9, which means that the cos inverse of 0.9 is x. Now, if the hyperbolic cosine of x is 0.9, it means e to the x plus e to the negative x over 2 is 0.9. Let me erase this and rewrite it. It is 0.9. Now, e to the x plus e to the negative x. In this case, if we multiply both sides by 2, 2 times 0.9 is 1.8. Alright? Now, if we multiply both sides by e to the x, we'll have e to the x squared plus 1 is equal to 1.8 e to the x. So it's 1.8 e to the x. Now, e to the x squared plus 1 minus 1.8 e to the x is equal to 0. Now here, if you consider making, let e to the x be equal to p squared minus 1.8p. This would be minus 1.8p plus 1 equals 0. I don't think this can be factorized, so let's use a quadratic formula. We could use completing the square as well, but let's just quickly use a formula and see what happens. P equal negative 1.8. So remember, once using the formula, carefully put in the values, right? This would be like you're saying x squared plus negative 1.8x plus 1 equals 0. It would be somewhat like that, right? So a would be 1, b would be negative 1.8, c would be 1, right? So remember, the formula says x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. It's quadratic formula. So x equal negative b, which is negative 8, plus or minus the square root of b squared, which is negative 1.8 squared. Wait, did I say negative 8 earlier? It's negative 1.8, right? So that's negative b plus or minus the square root of b squared, which is negative 1.8 squared, minus 4 times a, which is 1, times c, which is 1, all over 2 times a, which is 1. So p, negative 1.8 is positive 1.8, plus or minus the square root of, what is negative 1.8 squared? Let's work that out. We use our calculator. Negative 1.8 squared is the same as positive 1.8 squared because the negative signs would go. So what we have is 1.8 squared is equal to 3.24. So we have 3.24 minus 4 all over 2. Now notice, this is a smaller value than the 4. So you'll be trying to find the square root of a negative number. Right? You'll be trying to find the square root of a negative number. Because 3.24 minus 4 is a negative 0.76. Now, this value must not be smaller than 4. So this here must not be smaller than 4. So here, when you square this, this number must not be smaller than 2. This should not be smaller than 2. Right? So this here must not be smaller than 2. This must not be smaller than 2. Let's trace it out. This must not be smaller than 2. So this here must not be smaller than 2. Now here, 2 times that. This must not be smaller than 1. Because if this is smaller than 1, 2 times it is smaller than 2. Now here, e to the x plus e to the negative x over 2 must be not less than 1. Should not be less than 1. Right? Now, this is the cosh of some value here. This is the cosh of x. Cosh of x must not, well, must not be less than 1. Right? That means you're not supposed to be able to find the cosh inverse of a number that's less than 1. See that? So once it's anywhere under here, it cannot work. It cannot be less than 1. Alright? So the graph of the cosine, of the hyperbolic cosine, does not fall below 1. So when you find the hyperbolic cosine of an angle, you're never going to get a value less than 1. So if you try to find hyperbolic cosine inverse of a number less than 1, you get an error message. Alright? But anyway, this is the cosine of the hyperbolic cosine, the graph of the hyperbolic cosine.